This podcast is sponsored by the Red Hat Developer Program. Download our latest O'Reilly book, Building Reactive Microservices in Java. Learn why Eclipse Vertex is a good choice to build effective microservice systems. Download it now at infoq.link/Red Hat.
Welcome to the InfoQ podcast. I'm Thomas Betts, lead editor for architecture and design at infoq.com. I'm at QCon San Francisco, and joining me today is Chris Richardson. Chris, can you take a minute to introduce yourself?
Oh yeah, hi, I'm Chris Richardson. What can I say about myself? Well, I suppose I've been a developer for a very long time now. Actually got started in programming back in the 80s. In sort of more recent history, back 10 years ago, wrote the book POJOs in Action. So that was all about Spring and Hibernate. Then I started tinkering with Amazon EC2 back in 2007 when it was super obscure, and ended up creating Cloud Foundry, with the original Cloud Foundry, which was a PaaS for deploying Java applications on EC2, and that ultimately got acquired by SpringSource in 2009 and then by VMware. And so I was part of that for a while, and then for the past 3 years I've been pretty much focused on microservices. So I do consulting and training, help organizations use microservices effectively, and I'm also have a startup called Eventuate.io. We're building a platform to simplify the development of transactional business applications that use the microservice architecture.
I saw a tweet of yours just a week or two ago that I really liked. Said, microservice architecture is a better term than microservices. The latter suggests that a single microservice is somehow interesting. I think that's a good synopsis in 140 characters, but can you elaborate on that more?
Oh yeah. I mean, I'm trying to remember what motivated that. But I sometimes feel like it's almost with any new technology. You often see sort of older technologies getting relabeled as sort of microservice, or in this case, microservice frameworks. Same thing happened with cloud computing. And, so I think I just saw someone had described a framework as a microservice framework, and then I looked at it and I thought, well, that just seems like a web application framework. And hence, well, in reality, the microservice architecture is a way of architecting a system. And a microservice, if you want to use that word, is really, it is a component of a much larger system. And so it's sort of the term is only meaningful at sort of the system level. And I just think it's just really, really important to keep that in mind.
Right, so somebody can't think about, I'm going to just build a microservice and call it good. It's a complete design change.
Exactly. I've even I overheard some conversation. It's like, there's a problem. I know, we'll have a microservice for that. It's become sort of very buzzwordy.
Right. There's definitely that flavor.
So you got to just, even though it's from a sort of everyday communication point of view, it's often nice just to say microservices, but you always should remember it is a microservice architecture, which is a way of architecting a system.
Right. And so what else does that bring with it beyond, I have this little service and it just does one thing and it doesn't impact anyone else and I can horizontally scale it, whatever the aspects people see of a microservice. What else do you have to think of if you're getting started with, we're going to go down the microservice architecture path?
There's a ginormous list of features or issues that you have to deal with. So number one is sort of, how do you decompose a system up into a set of services? And, there, I suppose at a high level, it's like there's some notion of a business capability or a subdomain, to use sort of the DDD equivalent. And so that's roughly what a microservice corresponds to. You shouldn't think, I'm going to have 100 lines of code or something that's only going to take 2 weeks. It really should represent a meaningful capability that's part of your business.
Right, so like kind of a functional decomposition of the...
Yes, yeah. It's funny, we sort of throw all these words around business capability, functional decomposition, bounded context, subdomain. I mean, they're all a little sort of slippery in terms of what that really means, which is a big challenge, right? Because I mean, one of the scary things is that if you decompose your system in the wrong way, you're making a mistake at an architectural level, which can take a while. I mean, you've dug a very big hole for yourself, right? In the worst case, you've got a distributed monolith where every time you want to make a change to your system, you have to redeploy all of the services. And so in effect, you've got the complexity of microservices and the complexity of a monolithic system all simultaneously.
The worst of both worlds.
Yes.
Right?
Yeah.
Since you mentioned DDD, one of the factors or aspects of DDD is the ubiquitous language. And it seems like that also is now applying to the architectural discussion. As you said, functional decomposition or business case, or those terms are also, we need to understand what do we mean when we're talking about doing a functional decomposition of the system, or what do we talk about? Where are the business boundaries? How do you have those discussions with the business stakeholders and the technologists if you're proposing we're going to go down this architectural path?
Yeah. I mean, I mean, you definitely have to have this shared vocabulary. At a high level, I mean, what's interesting is, if you want to then get into DDD, each service is itself a bounded context with its own domain model and its own ubiquitous language. So there's sort of these two different levels of communication that has to happen, both sort of globally, but also in the context of an individual service.
And you're writing a two-part series on InfoQ about microservices and DDD and event-driven architecture. And I think it was event-driven architecture and CQRS. How do those fit in with microservices? Are they a good match, or is that something you have to struggle with to get microservices?
Yeah, I mean, it's really interesting because I look at the DDD book because, I mean, it's a fantastic book. But it came out in 2003, 2004, which is like ancient history. And it's a very philosophically motivated book. And what was interesting is there were definitely parts of it which did not really resonate well with me, right, at the time, where it was like some of the tactical building blocks, like entity, value, object, service, repository, and the like, that, from an sort of engineering perspective made sense. But then there was a whole bunch of fuzzy stuff, like aggregate, a set of objects that you can treat as a single unit. And then this even fuzzier thing called a bounded context. Which I kind of like, I guess I got partway through the strategic design or the strategic DDD or section of that book, but I didn't really pay attention to it. And the irony is that fuzzy stuff, from this ancient text is incredibly relevant to the world of microservices. As I mentioned earlier, a service is basically corresponds to or is a bounded context in the DDD sense. It actually has its own domain model. We no longer should think about having a global domain model for the system. They don't reflect reality and they don't scale. And so, this bounded context concept from DDD directly applies to microservice architecture. And then this concept of an aggregate, as I mentioned, that's a cluster of objects that can be treated as a unit. And there's some others, if you go read DDD, there's a bit more to it than that. But number one, aggregates have to comply with some certain constraints that fit exactly the technical constraints that you face within the microservice architecture. So number one, the aggregates can't have object references to other aggregates. They can only reference one another by basically a primary key, which is sort of a code smell from an object-oriented design point perspective. But when you want to put different domain objects in different services, you cannot have object references going between them. It just does not make sense. So this, yet again, concept from this sort of ancient text is incredibly relevant. And then another aspect of, another rule that aggregates have to sort of conform to is that a transaction can only update or create or update a single aggregate. And if you think about the constraints that you have to live in a microservice architecture, you cannot have distributed transactions. Each transaction has to be scoped to a service. And so this constraint on aggregates, which made no sense to me whatsoever when I read it, fits perfectly with this sort of no distributed transaction rule in a microservice architecture. So in other words, if you want to do microservices properly, go read the DDD book and take ideas from that, like bounded context and aggregate.
So the separation of concerns and the no transactions that are distributed, that seems to line up with CQRS. That you're going to have commands and queries are going to be separated as well. That one, it might be different services, it might be the same service, but you also have different responsibilities for updating the data and querying the data.
Yeah, I mean, so let's sort of back up a little. So, I kind of alluded to this, but one of another sort of key characteristic of the microservice architecture is that your services need to be loosely coupled. And one really important way of achieving that is for each service to have its own database. So you won't have a situation where two services are accessing the same database table, because that introduces coupling both at design time and also at runtime. And so we've got this sort of database per service model. So that's one thing. And at the same time, just like distributed transactions or two-phase commit is not a viable technology for sort of modern applications. So then the question is, well, how do we maintain data consistency across services? Because there is a business requirement to do that. Like our business logic just has business rules that imply consistency between what are now in different services. And so a good way to accomplish that is to use an event-driven architecture. Service A changes its data, it publishes an event. Service B responds to that event by changing its data, publishes an event, and so on. So we sort of have this whole notion of, I suppose the proper word for it would be saga, where you've replaced a distributed transaction with a sequence of local transactions where each step publishes an event that triggers the next step. And then another level is a good way to implement that is to use this pattern called event sourcing, which basically is an event-centric way of writing your domain objects or your aggregates and persisting them. You persist each domain object as a series of events, which then are replayed in order to reconstruct the current state. So that's sort of the events, events and microservices. And then the other piece of the puzzle is CQRS, where if you think about, just pick a piece of code at random that will, in a traditional application, that will execute queries that do joins across a whole bunch of tables, which in the microservice world are now spread across multiple databases and are owned by different services. And you can't just trivially write queries like that anymore. So it's sort of like, we want to split things up so we can develop fast, but transactions don't want to be split up, so we have to use a saga mechanism. And likewise, queries don't want to be split up either, but we have to do it anyway. And then the approach, the way of implementing queries is by using CQRS, where you've got a stream of events coming out of the business logic in response to creates and updates, and those events are used to keep views, materialized views of your data up to date, and then you run your queries against that.
And so since we don't have the distributed transactions and you've got these different materialized views coming, do you end up, there's some microservice architectures I've seen that have almost two layers. There's the worker layer down at the lowest point, they're connecting the database, and then above that's almost an aggregate layer, an API sometimes, where people interact with that. If you're writing something that calls and needs to use the microservices, you don't call down to every single individual one. You call into something that puts together a nice view. Is that where that happens? Does that make sense?
I mean, that could happen. Yeah. If you, so if you think about a request to sort of for an update request, that's likely to trigger the creation of a saga that will then go and update the relevant aggregates. So that's one part of it. And then if you think about an HTTP request to retrieve data, that could very well be executed against one of these CQRS views.
So one of the challenges basically every microservice architecture introduces is you're trading the simplicity, if you will, of a monolith. There's one thing to break, and we might not know what it is, but it's definitely in that one big monolith. Two, I now have tens or hundreds or thousands of microservices, and which one is broken? That introduces a different level of complexity and challenge. The first thing that comes to mind is deployment. So you're going to have to, instead of deploying the one big thing and getting good at that, you now have to get good at deploying lots of little things.
Yeah.
Does deployment become a first-class citizen in the microservice architecture world?
Oh yeah, absolutely. I mean, just to sort of go back up a level. I mean, microservices are not a silver bullet, right? Mm-hmm. I mean, there's no technology is a silver bullet. That's one thing for sure. And as someone once said, they're not a free lunch either. That the microservice architecture comes with a significant amount of complexity. So up until now we've covered one form of complexity, which is sort of around distributed data management, the need for event sourcing, and CQRS. But there's all these other kinds of complexity and complex issues that you have to deal with, and so deployment is definitely one of them. Before you had one presumably large application, and you just ran n copies of it, and that wasn't always easy, but it was kind of straightforward. Whereas now you've got tens or possibly hundreds or more services. So tens or hundreds of applications which are possibly written in a variety of different languages and frameworks, and language versions, framework versions, and so on. And you're going to run so many copies of each one for sort of availability, reliability reasons. And so you've just got a massive number of moving parts, or an order or two, magnitude more moving parts. And so, it's complex. So you're not going to be manually typing commands in to copy a WAR file to a server anymore, right? You need some kind of automated deployment infrastructure for that, sort of PaaS-like, though I'm sort of in quotes, because it might be what would be called a genuine PaaS, or perhaps it would just simply be a Docker orchestration framework, Kubernetes or what's built into Docker 112, for example. Just something that provides you with an abstraction of a service, this named thing, and it's going to run multiple copies of them and figure out where to provision them on a cluster of hardware, and just so that just provides this very high level of automation.
Then I think that kind of gets to my last question really is, when does it make sense to make the transition if you have an existing monolith to go into microservices? Is this a greenfield only, and we're going to be able to build all this new infrastructure and all those things and consider that and plan for it ahead of time? Or is there a safe path to say, we have this monolith, it's not working for us, we think we'll take the trade-offs of all the extra complexity that comes with microservices so that we can get the increased agility and other benefits?
Well, so I think the first thing to remember is sort of the microservice architecture is a solution to a problem, right? So first thing is, you have an existing monolithic application. Are you happy with the rate of development? And obviously there's a whole bunch of reasons why development might be slow, but let's imagine you're trying as hard as you can and you're doing all of the right things to make development go as fast as possible, and yet you're finding that it's really you need to go faster. Plus another thing is you've got some monolithic application and maybe your technology stack is obsolete, right? You've been building it for 10 years and technology has moved on. So actually in my class I call this monolithic hell, right? You're just in this world of pain where you can't be agile, you can't do continuous deployment, and you've got some out and the application is just degenerating into a big ball of mud, and you've got this obsolete technology stack. So if that describes the situation you're in, which I think is extremely common, like there's almost this inevitability, not always, but quite often you will end up if you're successful, you will end up with a large, complex, monolithic application, and it's just painful. So if you're in that situation, then you know for sure that, well, you got to do something, and quite often the answer to that will be to migrate to a microservice architecture. And and the way in which you do that is you definitely don't do a big bang rewrite, because that will almost always go badly, but you want to incrementally refactor your monolithic application into a set of services.
If you look around the internet, there's plenty of blog posts of all the new microservices things coming out. The thing I'm getting from you is a good recommendation is use all that to understand the Kubernetes or Docker and whatever the cool technology is, but go and read domain-driven design as a guideline of here's how you should set up your microservices and do the decomposition.
Yeah. Well, an awful lot of what is written in the context of microservices is in the realm of sort of deployment.
Mm-hmm.
And I think, say, like Docker is absolutely fantastic, but Docker is distinct from microservices, right? So it's like, remember, the microservice architecture is this architectural style where you functionally decompose your system into services. And one of the ways in which you could deploy your system is using Docker, but you could do it using virtual machines, or you could do it using serverless. There's a talk on, I think, AWS Lambda happening right now, right? So there are various different ways of deploying your system, and you've got there's a whole bunch of infrastructure concerns in addition to deployment, service discovery, and so on. But you've still got to figure out a way of implementing your business logic, right? That's the reason you've written your application in the first place. It's not to do cool things with some cool technology, but it's to actually, basically automate some business process that's critical to your business. And so that's where domain-driven design comes in, right? That's how, because that really is the core of your application. It's your business logic.
Well, Chris, I really appreciate your time. I think our listeners will appreciate this as well. Any parting thoughts?
No, I just enjoyed the conversation, and so yeah, go read Domain-Driven Design.
Yeah, that's a good recommendation for everyone. Well, thank you.
Thanks.